Hello everyone, good evening.
Good evening, sir.
Good evening, sir.
Okay, so have you all completed the content of week 12 yet or still in progress?
Completed, sir. Completed, sir.
Completed, sir.
Okay, so for today's Solve with Us session, can you all please go to joinpd.com and enter the code shown on the screen, which is TBAVBZ. Okay, so for now, I think most of you are aware of this that for every question, you will be given 5 to 15 minutes and keep a notebook and pen along with you so you can solve the question in the allotted time and then we can proceed further to discuss the solution for each of it. Okay. And for laptop and desktop, if you are using joinpd.com on the laptop or desktop, your view will be something as shown in the left side of the screen. And if you're using it on mobile, it will be something as shown in the right side of the screen currently. And our mobile users have to click on that button answer question to input the answers. Okay. Okay, so proceeding further, so this is the first question for today. Uh, the lifetime of a light bulb is exponentially distributed with a mean life of 18 months. If there is 60% chance that a light bulb will last at most t months, what is the value of t? So have you all understood what is exponential distribution and what is uniform distribution?
So then also you will you revise once only just the formulas.
Formula. Yeah, today we will keep on discussing formulas as we keep on facing it. Like in this question, we will discuss the formulas which will be used here, and also we will have revision session on 3rd August as well for week
Okay,
11,
sir.
12. Okay. So have you all like have an intuition of what actually is exponential distribution, what is uniform distribution, and how these continuous distribution are different from the discrete ones? Any intuitive idea to anyone?
Sir, revision session for 9-10 is already over.
Yeah, it was done last week only, I think. This week only we did, I think. Yeah, this Thursday we had. It will be available on the YouTube. You can go
Sir,
there and have a look at it.
Thursday for 11 and 12 now.
For 11 and 12, it will be on 3rd August. 9, 10 we just did this week only.
Sir, please one more extra revision session like solve with us session because 9, 10, 11, 12 has more weightage in end term exam if possible.
Yeah, so the 9, 10 session you can go on YouTube and have a look. 11, 12 we will have on 3rd August, and later if possible we will schedule one more session to discuss week 9 to 12 completely. If the
Okay.
time permits, we will schedule. Yeah.
Okay. It will be very helpful for us if you arrange one more session for 9 to 12 revision session.
Hello.
Yes.
Hello, sir.
Yes.
Am I audible? Actually,
Yeah.
I had an audio problem, so I was not able to talk to you. So I just wanted to confirm whether you can hear me now.
Yeah, I can hear you.
Okay. Actually, I was having a very low volume, so I could not hear you and I could not go to you, reach you also. So that's why I just called to confirm.
Okay,
This is
okay,
the
yeah,
first
that's it.
question, sir. I just joined, so it's the first question here.
Yeah, it's the first question.
Okay, okay, sir. Thank you, sir.
Okay, so do you guys need more time or are you able to solve it? Anyone need more time or done with the question?
It's done, sir.
Yes, sir, we can proceed.
Yes, there is a bit confusion between option B and option C. Okay. Okay. So before proceeding further, do you know what is the basic difference between PMF and PDF? Like you have seen discrete distributions, you have seen continuous. Now, what is the major difference you have noticed by now?
PMF is for discrete random variable and PDF is for continuous.
So how do we compute probabilities in case of continuous distribution? Let me give you an example. Suppose this is your PMF plot, okay?
We can just find the area.
Yeah. Okay. So the condition we always say is that that your probability should be greater than and equal to 0, right? And sum of all the probability should
One,
be
one,
One.
one.
Sir, what is the question?
what is the basic difference between PMF and PDF? Okay. So in case of PMF, these are your conditions, right? So suppose your x takes value 0, 1, and 2. So let's say this is 0.25. For 1 again, it's 0.25, and for 2, it's 0.5, right? So this is a valid PMF. Now proceeding to PDF, you might see sometime that it is possible to have values greater than 1 over this axis. Let's suppose this is, let's say, is uniform. Okay, so it is possible to have this, my function greater than, right, axis, let's say p3. Okay, it is possible to have fx greater than 0 and greater than 1 as well, right?
Yes, sir.
Because in continuous you always compute the area under the curve. So here all these condition for in case of continuous belongs to the area under the curve. That area under the curve should be greater than or equal to 0. And if you add up whole area, so this orange region area should be equals to 1. In that case, it would be PDF. So don't get confused if your PDF values is greater than 1 or something. Okay.
Yes, sir.
So now moving to this question. Okay. So lifetime of a light bulb is exponentially distributed with a mean life of 18 months. So what is the mean of exponential distribution firstly?
1 by lambda.
1 by lambda.
Expectation.
1 by lambda, right? It is equal to 18 months we are given.
Yes, sir.
So my parameter or lambda is 1 over 18, right?
Yes, sir.
Means my random variable x follows exponential parameter 1 over 18, right?
Yes, sir.
Yeah. Okay. Moving further, there is 60% chance that a light bulb will last at most t months. Okay, what does it mean by at most t months?
P should be
Le-
x less
Cumulative
than 16.
up to
Means
Less than
Less than or
Less
equal
than
to.
equals to t.
Less than equal to t.
Equal to
less
t.
than t, right? It has 60% chance, like 60% probability, right? Okay, so what is the CDF? It is a CDF, right? CDF of exponential distribution.
Yes, sir.
So what is the formula for CDF of exponential?
1 minus e
One
power
minus-
minus lambda t.
Minus lambda t. It is equal to 0.60,
0.6.
right?
Yes, sir.
Okay, so computing further, we get 0.40 equals e raised to the power minus lambda t, right?
Yes, sir.
Do you know how to solve this equation now?
uh, taking log both
Log
sides.
both sides.
Taking
logarithm.
log both
No,
sides, right?
sir.
Okay, so we take natural log both sides. So it becomes ln 0.40 ln e raised to the power minus lambda t. So natural log and exponential gets cancelled out. So that's something you might have studied in maths 1 for now. Okay. So ln 0.40 equals minus lambda t, right?
Yes, sir.
Okay. So minus 1 by lambda ln 0.40 equals to t, right?
Yes.
Okay, now compare it with the given options. So you see it's 1 by 18 ln 2.5, 1 by 18 ln 0.4 and 18. Okay, so we need to get it into positive, right? There
Yes,
is
sir.
no option
Minus.
in negative.
Yes.
Yeah. So first I am plugging in the value of lambda. So 1 by lambda is 18,
18.
right? So it's minus 18 ln 0.40 equals t. So whenever you take negative inside the logarithm, natural log, it becomes
Rise to the power. 1 by.
yeah 0.40 raised to the minus 1, which is nothing but 1 over 0.40. So if you solve it, so it would become 18 ln
2.5.
2.5. Is it clear to everyone?
Yes.
Any doubt in this? So you can see the solution part in the upcoming slides. So that's how we proceeded. This one. So option C would be the correct one, I
Correct.
think. Yeah, so those who chose option B, I think might have made mistake of that negative sign.
Yes, a mistake. Negative sign.
Okay, proceeding further, we have a probability density function. Okay, we have a PDF of time x in minutes. Okay, calls at customer. Okay, so you have some PDF for the time between calls at the customer care. So it is given by 1 by 2 e raised to the minus x by 2. Your x ranges between 0 and infinity. You need to find the probability at the time between calls exceeds the mean time. Okay, so before like proceeding the question, by looking at the PDF, you must be able to identify which distribution is it. Are you able to identify what is the distribution of x over here?
Exponential.
Exponential distribution.
Exponential, right? If I take my lambda is equals to 1 by 2, it is of the form lambda e raised to the power minus lambda x. Once you know that it is exponential distribution, I think this problem is a piece of cake now, right? So you all can proceed and try to solve it.
Whenever E occurs, it is understood no, that it is an exponential.
See, for now, like if you like in terms of stats 1 course, you only have 2 continuous distribution now, right? You know either it would be uniform or exponential.
Yes,
But
sir.
as you move to stats 2, that you will have this number of distribution increasing. So you must be able to identify that yeah, it is something relevant to exponential, something uniform. Like in discrete distribution, you must be able to identify when it is binomial, when it is hypergeometric. These things from the context of the question you should be able to identify.
Excuse me, sir.
Oh, yes.
Can I know what is e to the power minus infinity? Means I don't know.
Yes, so minus infinity, it's 0. So you all able to solve it or you need more time? Anyone?
30 seconds.
Okay. Okay, let's move further to the solution part. Okay, so you are able to identify that it was exponential distribution, right?
Sir.
That's the first thing we did from the question. So we know that our random variable follows exponential with parameter 1 by 2, right?
Yes,
Yes,
sir.
sir.
Okay, so what do we need to find in this question? We need to find that the time between call exceeds the mean time. Okay, so what is the mean time for this distribution? What is the mean?
2 minutes.
2.
2.
2. 1 by
1 by
2,
lambda.
right?
lambda.
Lambda, it is 2.
2.
Right. So we need to find the probability that
X
the
greater
value
than
of your
2.
random exceeds the mean time, which is 2.
Yes, sir.
So in other words, I can write it as 1 minus less than 2, right?
Yes, sir.
Which is nothing but 1 minus CDF of exponential distribution at point 2, right?
Yes, sir.
So we know by the formula of CDF it would be 1 minus e raised to the power minus
Lambda
lambda
t.
x.
Lambda.
So lambda is 1 by 2, right?
Yes, sir.
Your t is also 2. So it is e raised to the power minus
1.
1.
right?
Yes.
So yeah, so if such question comes in quiz and all, you don't need to remember the value of e. It would be either options would be in that format, or you will be given in the question that e raised to minus 1 equals this. So here it's 0.368. Okay. Any doubt till now, anyone? Okay. Okay, let's move to the third question. You might have similar questions in credit assignment as well. The time that Jan Shatabdi Express will reach the Delhi station is uniformly distributed between 12 p.m. and 2 p.m. You need to find the probability that train reaches Delhi exactly at 12:30 p.m. So important thing to note over here is you know that your random variable is uniformly distributed. It is given in the context of the question. You know the values like parameters of the distribution as well, right? It is 12 and 2. So you need to find the probability that it reaches exactly at 12:30, that your random variable x takes the value something 30 minutes, or how you describe your random variable, it depend on that. Okay, let's proceed to the solution part. Okay. Okay. So firstly, like in the beginning of the session, we have discussed that in continuous random variable, you need to compute the area under the curve, right? So suppose, let's plot it. So suppose this is your some 12 p.m. is over here, 12:30 is over here, and it goes on till 2 p.m., right? And we know that it is uniformly distributed. So let's say it would be somewhat this line, right? You all know for uniform distribution, the PDF is, if you plot it, it would be a straight line, right? Over some point here. Any doubt in this?
No, sir.
Okay. So we need to find the probability exactly at 12:30. Okay, so exactly at 12:30 means this line only, right? And but what is the area of line in general?
0.
Area of line is
line
0, right? So the area under the curve exactly at 12:30 p.m. would be 0, right? This area would be 0. So probability that your random variable will take the value exactly 12:30 p.m. it would be 0, right? So no need to do computation part in it. So for continuous distribution, we can generalize it. Whenever you have to find the probability at a specific point, it would always be 0 because area under the curve at that specific point would be line only. So it would be 0 always, right? Any doubt in this, anyone?
Sir, but why is it fast? In continuous, it is told in the definition that it is not defined in points. It is defined only in interval. Like,
Can you repeat?
I want to say that continuous distribution is defined only at intervals. No? So why are
Yeah,
asking exactly at point?
exactly at point,
Is here 12:30 is point.
right?
It is neither less nor more. Then how could we compute this in this continuous thing?
How do we compute the probability for this? You are saying something like this,
Yes.
right?
But in actual situation, it may appear that it may exactly come at 12:30, something like that.
Yeah, it may come at any point in between this 12 and 2, right? There are kind of
Yes.
infinite points in between 12 and 2, right? Infinite number of points, right? Like you cannot count how many points are there between 12 p.m. and 2 p.m. It could be 12, 12, 0. Like if you go in second, you can take every second, every millisecond as well, right? So in general, you have a large number of points in between them. You can never count it, right? So if you look at the general formula for probability, so total cases are very large, right? You cannot even count how many points would be there in between 12 and 2. While your favorable cases, it's only one, this specific point, 12:30, right?
Yes.
So if you go by probability, your favorable cases divided by total number of cases, which are very large, it would be 0, right? Because exactly 12:30 you mean, what does exactly 12:30 means? That 12 was 30 minutes and then it should be 0 seconds, 0 milliseconds, and any other further unit it has. So it is like very rare, extremely rare case to happen. 0 probability of it happening, right?
Yes.
Exactly this point. So that's how you can think of it by general probability rule. And for continuous, we know that to find the probability, we compute area under the curve. So here it would be a straight line. So area would be 0 only, right? Is this clear? Any doubt, anyone?
Sir, if this question is a continuous distribution, then what will be the difference in the words? It will be written continually distributed.
It is given that it is uniformly distributed, right? It means it
Yeah.
follows uniform distribution in between 12 and 2. So you are given the range of uniform distribution as well. So we in some sense know that it is continuous uniform distribution.
If it is to be given in continuous distribution, then what will be the question?
It is continuous, right?
Yeah.
Okay, so what exactly are you asking? Can you elaborate on it? Like here we have this question, right?
Yes, sir.
Sir, what she is asking is, because it is uniformly distributed, it is given. So we can understand that it is uniformly distributed. In
Yeah.
case of continuously distributed, in what way the question can be? That's what I understood.
Okay, so even if it is written that it follows some continuous distribution and you don't know its name, like which continuous distribution it is, then also you can compute that its value would be 0. But for the Statson point of view, the only continuous distribution you are studying is uniform and exponential.
Yes, sir.
So you would be able to identify which one of these is. But in general, for any continuous distribution you can think of, at a specific point the probability would be 0, right? For any continuous distribution. You can generalize it. And if it follows some other distribution and you need to find probability of some other events, then yeah, there are some properties of every distribution from using which you can compute. But for now, it's only uniform and exponential for you. Okay. Anything else? Anyone? Or shall we proceed further?
Sir, can't we take
Yeah.
the x minus a by b minus a formula, sir?
It is for CDF, right?
Yes, sir.
Yes, sir. I also taken the same formula. That's why I was getting confused. It means when to use this
Where
formula.
x is in between the interval, and we can take that x as 1230. Can't we take like that, sir?
Okay. This is formula for f of x, right?
Yes, sir.
It means that your random variable x takes the value less than or equal to this, right?
Oh, yes, sir.
But here we need to find that it
At
takes
exactly, yeah.
exactly this
Yes,
value.
yes, sir. Yes, sir.
That's
we
why
should
it is
have-
the CDF. Right?
Yes, sir.
Because CDF means all the possible values less than or equal to that point. But here our matter of interest is that it is equal to that specific value only,
Yes,
not
sir.
all the values below it. Okay.
Yes, sir. Yes, sir. Okay, sir.
Okay, proceeding further. Okay, the total duration of a badminton match in Premier Badminton League. Okay, it is uniformly distributed and you don't know the parameters, it's A and B over here. But the only thing you know is that the variance of this uniform distribution is 3, and you know the probability of an event as well. The event is that the match will last at most 42 minutes. The probability of it happening is 1 over 3. So you need to find the expected value of your uniform distribution. Okay, so in general you see that there are 2 parameters you need to find, and if you put in the context in terms of probability mathematically, you will be able to obtain 2 equations, one from the variance part and one from the given probability. So 2 equations, 2 variable, you would be able to solve and find the value of 2 unknowns, right? A and B. And using that, you can proceed further to compute the expected time.
For square minutes is the unit.
Yeah, variance, you always get the square units, right? So here unit is in minutes, so it's square minutes. It's a unit of variance. Okay, so anyone need more time or are you done with this question?
One more minute, sir.
Okay. Okay, let's proceed to the solution part. Okay. Okay, so what is the formula for variance of uniform random variable?
So the NP.
B minus A
B
square.
minus A whole square by 12.
So this is the information given to you, right? So first equation we know is that the variance of x, which is b minus a whole squared over 12 is 3, right?
3. Yes, sir.
Second equation given is that probability that the match will last at most 42 minutes. What is at most 42 minutes?
Less than or equal to.
to.
Okay, so you know its probability is 1 by 3, right?
So
These two
40.
equations. Yeah. Let's start with the first equation. So I can write it as b minus a whole squared equal to
36.
3 times, yeah, 36, right? And if I take square root both sides, it would be b minus a equal to either
Six.
plus 6.
Plus or minus.
Okay.
But you will not consider minus two.
Yeah, why we will not consider minus 6?
P is always greater than.
It cannot be
Yeah.
negative, both B and
Yeah, so b is always greater than a, right? So their difference can never be negative if b is always greater than a. So it must be positive only.
Yes, sir.
So from here we get that b minus a equals plus 6. This is our first equation. Okay. Second equation. So what is it? I can say that it is the CDF of uniform distribution at point 42, right? And
Yes, sir.
we know the formula for CDF. It's x minus a upon.
B minus A.
B minus A.
Okay, so here x is 42,
42.
right?
Yes, sir.
Minus a. B minus a, we know from our equation 1, it is
6.
6 is equals to 1 over 3. So on solving, we will get 42 minus a equals to, so a equals 40, right?
Yes, sir.
So to find b, I can put in the value of a in equation 1. So b minus 40 is equals to 6, which means my b would be
26.
46. So the information which I obtain from these two equations is that my x follows uniform with parameter 40 and 46, right?
Yes, sir.
Now we need to find the expected value of this. So what is the formula for expectation of uniform distribution?
A plus B by 2.
Yeah, a
So
plus
why
b by
can't you use minus 6 here?
because your upper limit should be greater than the lower limit of the uniform distribution, right? Yes, this b would always be greater than a. It is not possible for b to be smaller than a. So their difference can never be negative. It should always be positive only. Because b is the upper limit in some sense, or a is the lower limit. So it is the condition that your upper limit should be greater than the lower limit. So that's why their difference will never be negative. Yeah.
Sir, can't we here use like doesn't matter where A is greater than or B? We can take mod now.
We can
Actual
take
difference. I mean,
actual
if
difference.
suppose there is no any condition B is greater than A or A should be smaller than B, then we can take the actual difference between A and B.
Yeah, you can take absolute difference, but you should always keep in mind that this difference would never be less than 0 for sure.
Oh, okay, got
Okay.
it.
Yeah.
So how you get 40, sir? Because the equation will be 42 minus.
Okay. So it's 3 1, it's 3 2, right? So 42 minus a is equals to 2.
Okay. Okay, sir.
So a would be 40, right? Okay, so expected value would be nothing but 40 plus 46 over 2, which is 43.
43.
Any doubt in this, anyone?
No, sir.
No, sir.
Okay, so see, that's how we proceeded C. Because if we take B minus A to be negative, then A would be less than B and the condition would be violated. Where B should always be greater than equal to A. Okay. So yeah, that's how we proceeded it for the solution part. Any doubt till now, anyone, before we proceed further?
No, sir.
Okay, so it's again uniform distribution. You might see a similar question somewhere, I think, in graded assignment. Okay, so your random variable follows uniform distribution over the range A and B, and you know that expected value of your uniform distribution is 6 and the variance is 4. So you need to find the product of the two parameters of uniform distribution, which is A and B. What is the product of A and B? So here also remember, one equation you will obtain from the expected value and another equation you will obtain from the given variance value. Two equations, two unknown. On solving the two equations, you can obtain A and B like we did in the previous question, and then proceed further to find the required term. Okay.
Sir, can A and B come roots?
Uh, Sorry, can you repeat?
Can A and B be values in roots, square roots?
Yeah, it can be. Okay. So have you all able to do or need more time? Anyone?
Answer.
Yeah. Okay, so yeah, let's see how to proceed. Okay, so it is the same procedure as we did in the previous question, more or less. But let's see. Okay, so here again we know that our random variable x follows uniform distribution with parameter a and b, right? First equation is that expected value is a plus b over 2, it is equal to 6, right? Second equation is that variance is
B minus a whole square over 12.
it is equal to 4, right? These two equations are given. Two equations, two unknown. We must be able to solve for it, right? So from first equation, I can see that a plus b is equals to 12 if I multiply both sides by 2, right? In second equation, I'm getting b minus a whole square to be equal to
48.
48, right? Okay, so again, I can take square root on both sides, so I will get b minus a is equals to
4 root 3.
plus 48, yeah, and minus root 48. Again, I cannot take negative value, right?
Yes,
Because my b should be greater than a. So yeah, it would be something
4 root 3.
for root 3, yes. Okay, so we know that we have two equations, right? A plus b equals 12 and minus a plus b equals for root 3, right? Now if I add these two equations, I will get 2b is equals to 12 plus 4 root 3. Is this step clear? If I add these two equations, I will get 2b is equals to 12 plus 4 root 3, which means my b would be 6 plus 2 root 3, right? Any doubt till this step? Or is it clear? Okay. Proceeding further, if I plug in the value of b in any of my equation 1 or 2, let's put it in equation 1. So my a would be 12 minus 6 minus 2 root 3. So my a is 6
6
minus
minus
2 root 3, correct? So now what we need to find? We need to find
product.
product of the two, right? Which is 6 minus 2 root 3 into 6 plus 2 root 3. So those who remember the mathematical property, it's if I do x plus y into x minus y, it is equal to x square minus y square. Or you can also upon it by multiplying term by term, you will obtain the same result, x square minus y square. So it is 36. Okay, so it is
12.
your voice is breaking. It would be 4, 12. So the product is 24,
24.
right?
Yes, sir.
There's another way.
Yeah.
So, like, if we expand b minus a whole square, it becomes a square plus b square minus 2ab, which is equal to 48.
Yeah, you can approach like that.
Then
Yeah.
we square a plus b whole square. So it is a square plus b square plus 2ab is 144. And we subtract any equation from the other, we will get an equation in a.
Okay, so another approach could be, so you know this thing, right? So b minus a whole square, I can write it as b square plus a square minus 2ab, which is equal to 48, right?
Yes, sir.
If I add or subtract 2ab on my left hand side, it would be b square plus a square plus 2ab minus 2ab again minus 2ab equals 48. So what I did is I added and subtracted 2ab on the left hand side, so it doesn't affect my equation, right? It would remain the same. Now if you notice carefully this part, it is nothing but a plus b whole square, right?
Yes, sir.
Minus 4 times ab, which is 48. So we know a plus b is equals to 12. So 12 square is 144. Minus 4ab is equals to 48. So
4ab is equal to 96 and ab is equal to 24.
yeah, so ab is equals to 24. So either way you can approach. It's once you have two equations, it's now purely mathematical how you approach and obtain the value of a into b, right? Any doubt till now? Anyone? So here in the solution part, we have the second approach. Okay. Any doubt till now? Anyone? We're done with the 5 questions for now.
No doubt, sir.
Okay. Proceeding further, it's again uniform distribution we are having. Okay. So you know that uniform X follows uniform distribution and its PDF is given by this. It takes the value k whenever the absolute value of k is less than equal to 5. So absolute value of k means mod of absolute value of x. It means mod of x, right? So do you know what does it means? Mod of x less than equal to 5. What does this imply?
X lies between -5 to 5.
Yeah, x lies between -5 to 5. Okay. Anyone who has problem in understanding this absolute value part? Okay, no one. Yeah, then try to obtain the value of k. So Anyone need more time, or shall we move to solution part? Okay, let's move to solution part in that case. Okay. Okay, so how did you approach this one? Anyone want to share?
So area under minus 5 to 5 should be equal to 1.
Yeah,
Minus 5 to 5 integration.
minus 5 to 5. Yeah, it is uniform, right? So it would be a straight line.
Yes, sir.
1 minus b by s.
Okay, so in general, if you look at it, that this area should be 1, right?
Yes, sir.
Yes, sir.
So if you notice carefully, it is a rectangle in some sense, right?
Yes, sir.
So what is the length of rectangle?
10.
10, right? Breadth we need to find. We don't know what it is, right? And area we know 1. So L into B is equals to 1, right?
Yes, sir.
So 10 into B is equals to 1. So we know B is 1 by 10. It means, so this point is 1 by 10, right? This on the y-axis.
Yes, sir.
So it is your f of x, and here it is k. So k is 1 by 10 or 0.1. This is one way.
Yes, sir.
Another way, yeah,
1 by b minus a we can take, sir.
We can use that formula also, no? So 1 by b minus a.
1 by b
Yeah.
minus a.
so you can directly use the
Yes, sir.
formula for uniform
5
PDF.
minus of
Minus 5.
Right? So here you notice this is your A, this is your B, right?
Yes, sir.
So 1 over 5 minus of minus of, it is 1
1
over
by
10.
10.
So either way you can approach, by area approach or by the formula of
Sir,
PDF.
So
Integration.
1 by b minus a is the formula for what? Actually, I forgot.
It is the PDF of uniform distribution.
Okay.
Sir, also we can take integration that is x, or we can substitute the limit minus 5 to 5.
Yeah, you can also do that if you are aware of integration. Yeah, you can do that. So that would also give you the value of k. Okay. Any doubt till now, anyone?
Sir,
Yeah.
sir, I understood the process and I also solved, but the modulus, how you decided that the lower limit will be minus 5?
Okay, so here it is given that modulus of x should be less than equal to 5, right? The absolute
Yes.
value of x should be less than equal to 5.
Yes.
So if I take any value between 0 to 5, it would satisfy this equation, right? Now if you take any value in between minus 5 and 0, suppose I take minus 3, and if I take the absolute value of it, it is 3, right? So it also
Yes.
satisfy my equation. So this equation will
Sir,
satisfy
but
it
why
for,
minus 5? It's like why minus 5 is the end value, sir.
okay,
It can be
because here
minus 4.
it could be, see, minus 5
Minus
is,
infinity.
no. If you take minus infinity, this equation won't be satisfied. So the least value for which this equation is satisfied is minus 5. So this is your lower limit. While the maximum value for which this equation is satisfied is plus 5. This would be your upper limit. This is B and this is A. So lower limit to satisfy this equation is the minimum value will satisfy this given equation, right? If you take minus infinity, then minus infinity, you take modulus of it, you get infinity, and it is not less than equal to 5. So the least value which satisfy this equation is only minus 5. So we would take that as our
Okay, yes, sir.
low limit. Okay.
Yes, got it. Thank you.
Okay, proceeding further. Question number 7. Okay, this is the second last question for today. So PDF of random variable x is given by this. Okay, you don't know the distribution name here from the context given. Okay, and okay, so your PDF takes the value k times x whenever x is in the range of 0 to 1. You need to find the value of probability that your random variable x takes the value in between 0.2 and 0.8. And you are given the formula part in the hint as well. Okay. So you can use that hint part if you're not aware of integration. So you are given the integration formula to approach this question. Okay. Anyone need more time, or are we done with this? Okay, let's move to the solution part. Okay. So yeah, before that, let's see your responses. Okay, somewhat in between. Okay. Okay, so from the information, you can see that this information is given to you, right? That your PDF is k times x, and x lies between 0 to 1. So first thing, like before we have to compute this probability, you must find the complete value of PDF, right? Which means you first need to find the value of k, right?
Yes, sir.
Okay, so to find this, okay, so your complete area from 0 to 1, k times x should be equal to 1, right? And you know this formula, it is given to you also. So this, what is this formula? So a to b cx dx is equal to c times b square minus a square whole upon 2. Okay. So here you see your a is equals to 0, b is equals to 1, and c is equals to k, right? So plugging in the formula, you get k times b square minus a square, which is 0 square, divided by 2. It is equal to 1, right? So from here we obtain the value of k is equals to 2. So in general, our PDF, you see it is 2 times x, where x lies between 0 to 1. Clear till this step, everyone? Or any doubt?
So can't we apply that formula of one side b minus a here
No,
to
because it
find
is
k?
not a uniform distribution. In uniform distribution PDF, we only have a constant, but here the constant is multiplied by a variable x as well. So that's why you cannot use a formula 1 over b minus a. It is not the PDF of uniform distribution, or neither in the context of question it is mentioned that it follows uniform distribution, right? Right, so we have obtained the PDF, right? Any doubt till this step, anyone? Okay, so proceeding further, we need to find the probability within this range. It means we need to find the area of curve in between these points, right? And from the hint, it is given in the formula. So if you compare the formula with this term, your a is 0.2 this time, b is 0.8, c is 2. So plugging in the value, you will get c times, it was 0.8 squared minus 0.2 squared divided by 2, and you can compute it, right?
Yes, sir.
So
Can't we do f of 0.8 minus f of 0.2?
yeah, you can do it as well, but how would you obtain f of 0.8? You have to integrate from 0 to 0.8, right? And for f
Yeah.
of 0.2, you need to integrate from 0 to 0.2. Yeah, so both will give you the same answer. Okay, so don't be confused with it. It is a uniform distribution because its PDF is nowhere similar to uniform distribution, and neither in the question it is mentioned that it follows uniform. So be careful with these things. Okay. Okay, proceeding further, this is the last question for today, and I think it is again similar to one of graded assignment question. The traveling duration of a time taken every day by a train is uniformly distributed between 200 and 220 minutes. Okay, so you have some random variable x which denotes the duration of time, and it follows uniform distribution within the range 200 and 220, right? You need to find the probability that the duration of time taken is more than 215 minutes, that your random variable x takes the value more than 215, given that your x is greater than 210. So it is the kind of mixture of uniform and conditional probability, and you might see similar contextual questions in quiz or NTEM as well, where you will be having distributions and conditional probabilities you have to compute. So you give it a try. Okay, do you guys need more time or shall we proceed to solution part? Okay, let's proceed to solution part in that case. Okay, 4 out of range. Okay,
Sir,
so
conditional, please explain how to go about this.
yeah, we will come to it. Okay, see, so here this information is given to you, right? Right, and you need to find that your random variable x takes the value greater than 215, given it is greater than 210, right? Were you able to fetch this information from the question? Okay, so let's say your x greater than 215, it is event E, okay, and x greater than 210, it's some event F.
Hello, sir.
Yeah,
Can we take common by drawing a line or number line?
Common, how will you take common from it? It is conditional probability, not intersection. A common and intersection, right? Okay, suppose, okay,
Okay.
we will come to that thing also. Yeah. So let's suppose this is your event E, this is your event F, right? And you need to find probability E given F. Recall from week 8, what is the formula for E given F?
P of E
E
intersection
intersection F
by
Upon
P of
one P of F.
Probability of
right? So, but is E intersection F would be? E intersection F would be common region of the two, right? E intersection F means common region between the two events, right?
yes,
So, what is the common region in these two events?
210
Less than
115.
It's greater than 215.
Greater than 215, right?
Yes, sir.
And your F is the event greater than 210. Okay. So, for the numerator part, x greater than 215, we can write it as 1 minus CDF at the point 215, right?
Yeah.
And using the formula for uniform distribution, you can compute this. Similarly, for the denominator part, you can compute, and plugging in the values, you will obtain your final answer. Clear, right? Or any doubt in this? So expect such similar questions like the conceptual questions in term as well, where you will be given distribution and you have to link it with the conditional probabilities to compute. So even in the announcement, you have seen that the topics of major interest are random variable, distributions, and conditional probability, right? So that's it for today. Anyone, any doubt in the slides?
In the last one,
Yeah,
in the numerator part,
yeah.
it is 215 minus 200, no, sir?
Okay. Yeah, 1 minus 215. Okay, let me show you. So it is 1 minus CDF at the point 215,
Yes,
right?
yes, sir, yes, sir.
215 minus 200 divided by B minus A, right?
Yes, sir. Yes, sir.
So 1 minus 5 by 20, which is
Yeah.
15 by 20 or 3 by 4.
Yes, sir.
It should be 1 minus 15 by 20, which is 5 by 20.
Yeah, sorry. 1 which is 5 by 20, 1 by 4, right?
Oh, yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. Anything? Yeah.
Sir, the last question, I tried with some other thing, like I don't know whether my method is right or wrong, but somehow answer got matched. That is, I did like 10 by 20 for 210, which comes 0.5, and 5 by 20 equal to 0.25, and then I add these two and subtract from 1.
Okay, I don't think that would be correct, but somehow it matched. Yeah, but the actual approach, I think the only approach is the one stated in the solution slides. You have to use the concept of conditional probability, right?
Okay, thank you.
Okay, there's anyone any other doubt? Or shall we wrap up for today? You have another session at 8, right?
Hello, sir.
Yeah,
Can I ask one question from activity?
yeah.
It's activity A 12. Hello, sir.
Yeah. 1 minute.
Activity 12.3, last two questions. I tried lots of times, still I'm not getting answer.
Okay, yeah. Let me activity 12.3, right? Last two questions. Okay, how did you approach it?
So from the given diagram, I divided them into rectangle and triangle.
Okay.
First of all, I calculated the
Okay, so let me draw the diagram here. So it is something this, right? Trapezium going from here to here, right? This is point 10. This is point 12, right? This is 14. And this is 16, right? So firstly, you need to find the peak of the curve. So how did you find the peak of the curve?
so the total probability is 1. I calculated this triangle probabilities.
Yeah,
Means
area under the curve
the
should be
value of
1, right?
So area under the curve equal to 1.
Yeah, so you can either compute the area of this part, all the 3 parts, first, second, third, or you can directly use the area of trapezium, right?
okay.
So area of trapezium is sum of parallel side. So sum of parallel side would be 2 plus 6, right?
So the value should be 16 and 18, not
Sir,
14.
the end point is 18.
Okay, okay. So it would be 16 and 18. Okay, so what is the area of trapezium, anyone?
Half height into sum of
Half
parallel.
base into half sum of
Right.
parallel side.
A plus B.
Okay, so halves, we don't know this height, right? We don't know the peak. And
Yes.
sum of
Yes.
parallel side, it is 4 plus 8, right? It should be equal to 1 because the area of trapezium should be 1, right? Area under the curve.
Yes.
So from here, you obtain your height is 1 by 6. So this point is somewhat at height 1 by 6, right?
Yes, sir. I got the same answer.
Okay, for the second part, it is you need to find the probability that delay is less than 15 minutes, right?
Yes, sir.
So suppose your point 15 lies somewhat in here, right?
Sir, in question, middle value is 14 is given.
Yeah, so 15 would be in between
Yes, sir.
14 and 16, right? So less than 15 means you need to find the complete area from
Yes, sir.
10 to 15, right? So you can consider it as another trapezium, right?
Okay.
This trapezium over here. So we know the height, right? Height is 1 by 6. Sum of parallel side would be this
5
12 to 15. Yes, 3 plus 5. So this will be the probability your random variable takes less than 15, right?
Yes,
Is
sir.
this step clear?
Yes, sir.
Okay. Now moving to last part, but is a predicted delay in the train will be more than 11 but less than 14. So for that you would compute the area in between 11 and 14, right?
Yes, sir.
Will you be able to complete this now?
Yes, sir. How much is the value?
Value for
Oh, question 6. Answer.
question 6 answer, I think you can compute it, right? So it would be 1 by 2 times height times sum of parallel lines. So it would be
2 by 3.
2 by 3.
2 by 3, right? 0.67. Similarly, for question 7, you have to compute the area between this 0.11 and 0.14. Try to do this, right?
Okay, sir.
Okay. Anyone, anything else?
Sir, I have a doubt in hypergeometric distribution.
Okay.
Sir, in case suppose if a bag contains some, let us suppose some 3 colored balls are there, some
Okay.
red, black, and white.
Okay.
And suppose if our question is with respect to drawing a red ball, in
Yeah.
that case also can we divide it into 2 parts, that one is red and the other is
Non-red.
non-red?
Yeah,
we
you
can
can.
go for this concept, no sir?
Yeah,
Am I
you
right?
can. Yeah, you are right.
Yes, that is my doubt, sir. Or is it strictly defined only for 2 colors, something like that?
Yeah. So you are able to just divide into 2 categories. One
Yes,
should
sir.
be your category of interest and other should be remaining ones.
Yes, sir. Thank you, sir.
Thank you. Okay. Anything else, anyone? Okay, I think. Okay, so
Sir, in one
next,
of our revision sessions,
yeah,
mathematics revision and stat 1
yeah, we have changed the
are on
timings.
the
You
same.
can check.
Oh,
We have
I didn't
changed the
see.
timings. Yeah.
Okay, sir. Okay,
Okay.
sorry, sir.
Yeah,
I
we will
didn't see
also
today.
have some. Yeah, we will also have some on-demand sessions next week.
But
Sir,
still
will it be in
calendar
the
has not yet
evening, sir?
updated, sir.
Yeah, it can be in the evening as well. Okay.
Sir, will it be in the evening?
Yeah, it will be in the evening. What time is suitable for you all? We can keep it that time.
Yes, any time after 6, sir.
Okay, okay. We will do that. Okay.
Thank you.
Okay, guys. Meet you next week. Thank you, everyone.
Thank you so much, sir.
Thank you,
Thank
sir.
you, sir.
Have a good day, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.